Hello friends, today we are going to study the algorithm for heap sort. We are given an array and we want to sort this array in increasing order by using heap sort. So first step is to convert this array in binary tree form. Let's do that. So the first element is 8, next element is 7, then 9, then 10, 3, 4, then 1, 12, 6 and 5. So what I have done here is that I have just written all these elements sequentially. I will write the indices of the elements so that you can better understand. These are the indices of the elements in the array. Now we have to convert this binary tree into a heap. So now what is a heap? There are two types of a heap. One is mean heap and the other one is max heap. In mean heap, value at each node is always less than its children. For example, here 1 is less than 3 and 6, 3 is less than 4 and 9, 6 is less than 7 and 12. So value at each node is less than its children. And in max heap, value at each node is always greater than its children. So here 14 is greater than 6 and 12, 3 is greater than 1 and 3. So it is greater than or equal to, and here also it is less than or equal to, means here it can be 4 also, because 4 is less than or equal to 4. So now let's convert this tree into a heap. For converting the tree into heap, we use a method whose name is Heapify. So let's see how this method works. Always start above the level of the leaf nodes. That is the second last level. Now, 10 is a node and 12 and 6 are its children. So I will make a circle here. So out of these three nodes, which node has the minimum value? Yes, 6 is minimum. So we have to swap 6 with 10. Then go to the next node on this level. So that is 3. 3 has one child. Make it a circle. So out of these two nodes, what is minimum? 3 is minimum. So there is no need to swap because 3 is at its correct position. 4 and 1, they don't have any child. So let's go to the upper level. Now 7. 7 has two children, 6 and 3. Let's make it a circle. So what is minimum in these three? So yes, 3 is minimum. So let us swap 3 with 7. Go to the next node, 9. 9 has two children, 4 and 1. So I have made a circle. So what is minimum in these three? 1 is minimum. So we will swap 9 with 1. Go to the upper level. Yes. Let's make a circle. 8 has two children, 3 and 1. What is minimum? 1 is minimum. So let's swap them. So we have applied the first step. So the question is that how many times we have to apply the Heapify method on the binary tree. So I will answer it. First, I will write this tree clearly. 1, 3, 8, 6, 7, 12, 10, 5, 4 and 9. So you have to check each node of this tree whether all of them satisfy mean heap condition or not. Means we have to check each node whether it satisfies mean heap condition. So let's check it. 1 is less than 3 and 8. Yes, it satisfies. 3 is less than 6 and 7. It's okay. 6 is less than 12 and 10. It is okay. Yes, 7 is not less than 5. 7 is greater than 5. So this means that this tree is not mean heap or it is not heap. So we have to apply Heapify method again. So let's start from this level. 6 has 12 and 10, so this is okay. 7 is greater than 5, so we have to make it a circle and we have to swap. 5 comes here, 7. No problem with 4 and 9. Let's go up. So with 3. So out of these 3, is there any problem? 3 is less than 6 and 5. So there is no problem. 8. Yes, 8 is greater than 4. Means we have to swap 8 with 4. Now go to the upper level. 1. 1 is less than 3 and 4. Yes, so this is okay. Now check here, each node satisfies the heap condition, that is mean heap condition. That is, each node value is less than its children. So we have created the heap out of this array. This is the first step towards heap sort. Now I will explain you heap sort. So let's start with heap sort. So this is the heap which we formed in our last step. Now as this is the mean heap, the root node is always the minimum element in our array. The array we have converted into this binary tree, so we can say 1 is the minimum element in this tree. So we note it down. Now the method is that we remove this 1 and replace this 1 with the last element in the tree. So what do you mean by last element? You must be remembering I had numbered this binary tree in this sequence 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 index 9 is the last element. So that is 7. So I will keep 7 here. Now after keeping 7 here, now it is the time to heapify the tree, because after we replace 1 with 7, this tree doesn't remain the heap, because now it does not satisfy the property of mean heap. So now let's heapify. So out of 12, 10 and 6. So as you know, we have started from the second last level. I will circle this. So from 6, 12 and 10, what is minimum? Yes, 6 is minimum. So 6 is at its correct position. So there is no need for swap. I will just delete all this. Okay. Now the next element 5. So for 5 there is no child now, as 7 has went up. to the root. 8 has no child and 9 has no child. So let's go to the upper level. Now 3. 3 has 2 children, 6 and 5. Let's make it a circle. So what is minimum in these 3? 3 is minimum. But 3 is at its correct position. So there is no need of swap. Now 4, 8 and 9. Yes, 4 is at its correct position. Let's go to the upper level. 7, 3 and 4. Let's make it a circle. So yes, here 3 is less than 7. So we have to swap 3 and here 7. Let's check whether this satisfies the heap condition. 3 satisfies 7. 7 is greater than 5. This means that we need another heapify method. So first let's write this tree clearly and then apply the second heapify method. Again I will tell you why we are applying the next heapify method. Here we check each element whether it satisfies the heap rule or not. So we got this 7 which does not satisfy the mean heap rule because 7 is greater than its child 5. So we apply heapify method. Let's start from this level. So from this level, so out of 6, 12 and 10, what is minimum? 6 is minimum and it is at correct position. 5, 8 and 9, they don't have any child, so there is no need to process. Go to the upper level. Out of 7, 6 and 5, what is minimum? 5 is minimum. So we have to swap 7 with 5. Okay. Then go to the next element. 4, 8, 9, what is minimum? 4 is minimum. So 4 is at its correct position. Now go to the upper level. 3. So let's circle it. Out of 3, 5 and 4, what is minimum? 3 is minimum. So 3 is at its correct position. So now let us check. First we will write it clearly and then we will check it. And 10. So let's check each element whether it satisfies the heap condition or not. So 3 is less than 5 and 4, 5 is less than 6 and 7, 6 is less than 12 and 10, 4 is less than 8 and 9. So each element satisfies the mean heap condition. So this means that we have created another heap. So as this is a heap, the root element is the minimum element in all this tree, in all this heap. So we have got the next element in our sorted array, that is 3. You have to always take the root element and keep it here. That is our sorted array. So remove the root element. We have kept it in the sorted array. Now replace the root element with the last element. As you know the numbering, this is the last element. So this child is gone and will come here. So now 10 is at the root. Again, now this tree does not satisfy the heap condition. So we have to apply heapify method here. So let's start. So 6. 6 is less than 12, which is okay. 7, 8, 9, they don't have any child. Let's go to the upper level. 5 is less than 6 and 7, which is fine. 4 is less than 8 and 9. Okay. Yes. 10. 10 is greater than 5 or 4. So What is the minimum in these three? 4 is minimum. So swap 10 with 4. Now let's check whether this is a heap or not. So 4 is satisfying, 5 is satisfying, 10. 10 is not satisfying the rule as 10 is greater than 8. So let's again apply Heapify method. So let's first write it clearly and 12. Let's apply Heapify. 6 is less than 12. All the 3 doesn't have any child, so no problem. So this level is over. Now let's go to the upper level. 5 is less than 6 and 7. Okay. 10. So at this level 10 is greater than 8 and 9. So what is minimum in these three? 8 is minimum. So we have to swap with 10. So is it a heap now? Yes, each element satisfies the heap condition. So this is a heap now. As this is the heap, the element at the root will be the next element in our sorted array. So now just remove this element and replace that element with the last element. So 12 comes there. Again, this doesn't remain a heap. So let's heapify. I will write it clearly first. 9. So let's apply Heapify method. This is the level above the leaf level from which we have to start. 5 is less than 6 and 7. 8 is less than 10 and 9. But let's go to the upper level. 12 is greater than 5 and 8. So this doesn't satisfy the condition. Now we have to apply the Heapify method. So here, yes, we will circle it first. Then what is the minimum in these three? 5 is the minimum. So we will swap it. 5 comes here, 12 goes there. So let's check now. 5, 12, yes, this doesn't satisfy the condition. So out of these three, what is minimum? So the minimum is 6. So we have to swap 6 and 12. So let's see whether every node satisfies the condition or not. 5 is less than 6 and 8. 6 is less than 12 and 7. 8 is less than 10 and 9. Yes, this is a heap. As this is the heap, now let us first write it clearly. So now, as this is the heap, the root element will be the next element in our sorted array, and you will replace it with the last element. As you know the numbering, 0, 1, 2, 3, 4, 5, 6. This is the last element we have taken. Now, as we have taken the last element at the root level, this doesn't remain the heap again because 9 is greater than 6 and 8. So now let's heapify this. Go to this level. 6 is less than 12 and 7. 8 is less than 10. let's go to this level. 9 is greater. So out of these three, what is minimum? 6 is minimum. 6, 9 and 8. Let's check whether each thing satisfies 6, 9. Yes, 9 doesn't satisfy the heap condition because 9 is greater than 7. So again apply. Now 7 is minimum, so we will swap this with 9. Now check. Yes, every node satisfies the condition. So this means this is a heap. So the element at the root will be the next element in the sorted list. Yes. So just swap it. 9 will come here. I will just write it clearly first. 7, 8, 12 and 10. So now check. 9, yes, doesn't satisfy the condition. It doesn't remain a heap again. So let's heapify this level. 8 is less than 7, yes. So 9 doesn't satisfy the condition. 9 is less than 7. Out of these three, what is minimum? 7 is minimum. Yes, this is a heap now. So we have got the next element. So swap 7 with the last element. You know the ordering 0, 1, 2, 3, 4. Here was 10. So 10 comes here. So now let's check whether this is a heap. 10 is greater than 9. This is not a heap. So let's apply heapify method. So I will apply it here only. So 9 is less than 12. 8 doesn't have any child. Let's check this. Out of these three, what is minimum? 8 is minimum. So we will swap 10 and 8. So now I think this is the heap now. So we have got the next element. So 8 is here. We will swap 8 with the last element. Last element was 12. So now check whether this is a heap or not. No, this is not a heap. So let's apply heapify. Now the leaf level is this and level above leaf level is this. So what is minimum in this? 9. So let's swap 9 with 12. 9. As this is a heap, we have got our next element here. Now let's check this 9, 12 and 10. So as we got the 9 here, we will replace this 9 with the last element 0, 1, 2. This is the last element. 10 will come here. Is it a heap? Yes, 10 is less than 12. So we got our next element 10. So we will remove this. We will swap this position with the last element, that is 12. Is it a heap? Yes. 12 doesn't have any child, so this is a heap. So we write 12 here. So in this way, by using heap sort, we have sorted the array, that is this binary tree. So now let's see the algorithm. This is the algorithm. First, heapify the array means, as you know, we apply the method and create a mean heap out of the array. Then next, you have, once it is a heap, you know the first element is the minimum element in the array, in the sorted array. So take the first element in sorted array. We shift the first element into sorted array. Then what we do, we replace the first position. As we have removed the element from that position, the first position is empty. So we replace the first position with the last element. Then after moving the last element to the top, that is the first element, we check now this remains a heap or not. That is here, check if the tree is a heap. If yes, it is still heap, then just go again and take the first element in sorted array and perform the procedure. If no, then go to 1. If it is not a heap, then again heapify and create a heap. So this you have to do until the elements are over. So for writing the program, I have to tell you an important thing here. This array, we are going to consider this array as a binary tree, which I said previously. But we are not going to create any binary tree here. Actually, we are going to use this array as a binary tree. So what this means? So this array is converted to this binary tree, for example. So here you can see the position 0, the index zeros, children elements are present at location 1 and 2. So for position 0, 1 and 2 are its children. So index 0, its left child is at position 1 and right child is at position 2. Similarly, for index 1, 5, its left child is 2 and 7. Its left child is 2 and 7. So their positions are 3 and 4. Means for index 1, its left child is at position 3. This 3. Then and right child is at position 4. This 4. So we understand from this that if index is I, then its left child will be at index 2i plus 1 and right child will be at index 2i plus 2. So by using this, we can use this array as a binary tree, and which I have done in the program. You can get the full program on this website. Here I have uploaded the code, so you can use this code for your work. Thank you.